Hello ladies and gentlemen, and welcome back to our Algebra 2 distance learning here with Mr. Hagedorn. Today's lesson is 8.3, Define and Use Probability. When you talk about probability, generally what you are talking about is what's known as theoretical probability. Theoretical probability is when all of the outcomes are equally likely to happen. This is what should happen. So when you talk about probability in its just general form, it's the number of outcomes in event A over the total number of outcomes, as you can see in our little display there. There are 3 events that occur in event A, and there are 8 outcomes overall, so the probability of choosing something from event A would be 3 out of 8. Another way that we'll talk about this, or you'll hear me say from time to time, is that it's the number of successes over the total number of outcomes. So if we take a look at a standard deck, now when we talk about a standard deck of cards, we're talking about a 52 card deck with 4 suits: spades, clubs, hearts, and diamonds. And then the playing cards themselves are ace all the way up to king. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king, queen. So each deck has 13 separate cards in 4 separate suits. That's where we get the 52 from. So if we are looking for the probability of picking an 8, we'd have to look at, first of all, how many 8s do we have in the deck? The answer is we have 4 8s. And then, as we already mentioned, we have 52 total cards to choose from. So in this case, the probability of choosing an 8 would be equal to 4 over 52, or simplified down, the probability would be 1 out of 13. Now if we take a look at the next example that we have here, finding the probability of picking a red king. Well, in this case, we have to look at how many kings we have and how many red kings we have out of our 52 card deck. Overall, there are 4 kings in the deck. However, only 2 of them are red, the king of hearts and the king of diamonds. So in this case, we would have 2 red kings as our successes. The total number of cards, again, is 52. So in this case, the probability of choosing a red king would be equal to 2 over 52, which simplified down would give us our final probability of 1 out of 26. So again, as you can see here, ladies and gentlemen, with simple probability comes simple fractions. We're not looking to overthink this at all. We're just looking to introduce and understand what probability is. So here's one that's probably a little bit, I guess you'd say it'd be more famous than any of the others, and that's when you play a lottery. Here I have 2 scenarios that we're going to take a look at. And in these scenarios, what we're looking for is the total outcomes that we would have in any given situation. And then on top of that, we're looking for the total successes that will help us find our probability. Okay? So if we take a look at the first scenario, it says you must correctly select 6 out of 48 numbers. The order of the numbers is not important. So since it says right there that the order of the numbers is not important, that leads me to believe that we're going to be dealing with combinations. So in this case, the first one that we have to take a look at is the 6. If we are looking to choose 6 out of 6, but the order doesn't matter, then the top here would be the combination of 6 objects taken 6 at a time. The total number of outcomes is we're looking to choose 6 out of 48. The change comes because in the numerator, we're looking for all of the possibilities of choosing 6 numbers out of the 6 numbers that we have. On the bottom, we're looking of choosing 6 numbers out of the total of 48 that we have. So punching this into the calculator, and the top 6 combination 6 would be 1, which makes sense. How many different ways can you choose 6 out of 6 if order doesn't matter? It's only 1. And now the bottom, 4C 48C6, excuse me, or the number of combinations of 48 objects taken 6 at a time, ends up being 12,271,512. So what's the likelihood that you'd win that lottery? Not very good, but it does show you that as the number of total outcomes increases, your probability does decrease a little bit. Now the next one, it says you must correctly select 4 numbers and each integer is from 0 to 9. Order is important. So if you look at this again, you must select 4 numbers, each an integer from 0 to 9. In this case, order is important. So when we look at this, we have to look at it from the standpoint of we have a 4-digit number, and each one of those digits has 10 separate outcomes. So again, how many ways could you correctly choose 4 numbers out of 4 numbers? The answer here would be 1. So the total number of successes, again, is 1. But now the denominator, if we take a look at this, each is an integer from 0 to 9. So that means the first of our digits could be 10. 10 choices. The second one has 10, the third one has 10, and the fourth one has 10 separate choices. So in this lottery scenario, there's only one correct 4-digit number that would give us the overall jackpot. But the denominator shows us that each one of those digits, each one of those integers has 10 choices. So this, ladies and gentlemen, goes right back to the fundamental counting principle. So in this case, the probability of success would be 1 out of 10,000. Both of them set up based on what was needed. In the first one, we just needed groups. Order's not important. And the second one, we used the fundamental counting principle since order was important. So now we're going to take a look at something that's generally closely related to probability, and that's odds. Odds in favor of and odds against. So when we take a look at odds, odds is not the comparison of successes to total outcomes, it's the comparison of successes to failures. The way that it's said here is it's the number of outcomes in A versus the number of outcomes not in A. So again, I would simply say that that would be success over failure. And its counterpart, odds against, just flips that. It's the number of failures over the number of successes. When we write this, there are 2 forms that are acceptable, but the one that's most common is using the ratio in the form of A to B using a colon. You could write it as a fraction, but the reason that I generally teach it as a colon is because fractions are probabilities and the colon, those are odds. So now what we have to take a look at is just a very basic, easy to explain example of how to do this, and that's using a standard 6-sided die to roll. So just your normal number cube, you'd see it in a game, you'd roll it, it's got 1 to 6 on it. So now what we're looking for is what are the odds in favor of rolling a 6? So in this scenario, what we have to take a look at is how many successes do we have? Well, for success, the only thing we have is rolling a 6. If we look at failures, that could be 1, 2, 3, 4, and 5. So those are all the failures. So in this case, the odds in favor of rolling a 6 would be 1 success to 5 failures. So the odds are 1 to 5. So in this case, I would say the odds are against us being successful here. But now the other one, the next one that we have, we're looking to find the odds of rolling an odd number, okay? Rolling an odd number. So in this scenario, odds against mean it's failure to success. So our failure here would be rolling an even number, 2, 4, 6. A success would still be the odd numbers, 1, 3, and 5. So in this case, if you take a look at it, this gives us what's known as even odds, which means it's just as likely to occur as it is not to occur. And just like in probability, we always want to put our answers in lowest terms, so if we can factor something out of both, we will. So in this case, the odds would be 1 to 1, because there are as many odd numbers as there are even numbers on that die. And the last thing I want to show here, ladies and gentlemen, is experimental probability. Experimental probability is the probability that we get from an experiment being performed. Theoretical probability is what should happen. Experimental probability is what did happen, okay? Again, it's still comparing successes to total outcomes, and then we'll take a look at not only that, but then we'll compare them to one another, experimental to theoretical. So in this case, after the rolls were all done and they were all tabulated, there were 27 ones, 22 twos, 18 threes, 26 fours, 27 fives, and 30 sixes. So now what we're looking for are the total number of outcomes being 150 for the experimental, but for the probability that we would have that would still be theoretical, it's 6, because there are only 6 numbers on that numbered cube. So the probability of rolling a 5 in this case, probability, the experimental probability in this case would be 27 over 150, which if you divide that out is about 0.18. The theoretical probability of rolling a 5 here would be 1 out of 6, which is about 0.17. So notice here that in this case, the theoretical and the experimental probability are about the same. Now rolling an even number, in this case, the experimental probability, if you add up the 2, the 4, and the 6, you end up with 78 over 150, which again, if we would write that as a decimal, would be about 0.52. The theoretical probability of this on a number cube would be 1 out of 2, which would be 0.5. So once again, those two are about the same, which you do see happen more often than not. Now the next one, rolling a number less than 5, so that would be anything 1 to 4, the probability there would be experimental 93 over 150, which is about 0.67, or 0.62, excuse me, and the theoretical probability on this one would be 2 out of 3, which would be about 0.67. And again, those are relatively the same. And the last example that we have here is rolling anything that's not a 3. So experimental probability would put that at 132 out of 150, which is about 0.88, and the theoretical probability on that one would be 5/6, or about 0.83. And you'll find that the comparison of these two is generally about the same. The more outcomes that you have, the closer the experimental and theoretical probability are going to be of coming together. All right, ladies and gentlemen, that's it for today. Please take the time to go through your practice worksheets. If you have any questions on them, please bring them to our meeting time this week. Other than that, Lord's blessings on your day, ladies and gentlemen, and I look forward to talking to you soon. Bye now.